Greetings, everybody. I want to take a moment to solve a derivative problem that involves multiple rules all happening at more or less the same time. Okay? And that would be this one. And if I was to find the derivative of this function, it would involve me using both the chain rule and the product rule. Okay? I did get this problem from my math lab. Here's what it looks like there. But let's talk about how to do it. So first of all, this original function is the product of two functions, and so I would need to use the product rule to find the derivative. But the product rule is going to involve the derivatives of each of these individually. Okay? So for example, if I say, well, this function is a function f times another function g, then the product rule is going to say, well, the derivative will be f prime times g, and then plus g prime times f. So I thought before I got started on all that, I would find the derivatives of each of these functions individually. Now, when you find the derivative of 2x plus 4 all to the 7th power, that will involve the chain rule. Okay, and that would look like this. I bring that 7 to the front, take away 1, I get a 6. The derivative of that interior function, 2x plus 4 is 2, and that gives me 14 times 2x plus 4 to the 6th power. The derivative of this other function, g, root x, that's going to be 1 over 2 root x. Okay, so that's everything I need to get started. So given the product rule is now applicable at this point, I say, all right, y prime, the derivative of this function, f prime g, g prime f, is 14 times 2x plus 4 to the 6th power times g, which is root x, plus g prime, which is 1 over 2 root x, times f. Okay? Looks like that. Now, in order to get anywhere with this, as far as simplifying goes, I need to add these two things together. Okay? And in order to add these two things together, one of them I notice is explicitly a fraction. This is 2x plus 4 to the 7th power divided by 2 root x. And this other one's not, but regardless, if I'm going to add these two things together, these two fractions, I need a common denominator. So I took this here, 14 times 2x plus 4 to the 6th power times root x, and I multiplied by 2 root x over itself to get a common denominator. And that would give me this, okay? Got 2 times 14, I get 28, root x times root x, x, 2x plus 4 6th power over 2 root x. Okay, so now I'm adding two things, two fractions with a common denominator. I've got this plus 2x plus 4 to the 7th power over 2 root x. They have a common denominator. Adding them together at that point gives me this. Okay? Now, from here, I notice that some factoring can be done. Like in this term right here, I got 2x plus 4 to the 6th power. And in this term right here, I got 2x plus 4 to the 7th power. They have something in common. They have 6 of 2x plus 4 in common. So think about it like this. I'm taking that common part away, and then I can re-multiply and prove to you that it's right. What's 2x plus 4 to the 6th power times 28x? That gets you this first term. What if I multiply it times this second term? What's 2x plus 4 to the 6th power times 2x plus 4? That gives you the 7th power, see? All right, so I factored that out. That allows me to condense it a little bit. And then I realize with the residue in here, the stuff that's left over after I factored, I got 28 and 2, that makes 30, like so. Okay. Now, from here, I notice that there's some redundant factors of 2. I've got a 2 on the bottom right there. And between 30 and 4, they have a common factor of 2. So let's say we just look at that. We factor out the 2, and then it's sitting up there where we got a 2 and a 15x plus 2. And 2 and 2 cancel, leaving me 15x plus 2 on top, 2x plus 4 to the 6 on top over root x. And then we're done, all right? But that's how we simplify it. The first step was the derivative, maybe not that bad. The rest of it, the algebra, might be the harder part, and that's somewhat typical with calculus problems at this level in our class. But there's some algebra for you to think about. And the fact that you're getting a common denominator is required to add these two things together. The fact that that's what they look like when you add them together. Factoring out this 2x plus 4 to the 6th power. We've got to see that also. Anyway, so I put that answer in, and it's the one that it's expecting, and it's correct. All right. Now you'll find a similar problem for you to try in the assignments. And if you needed any help with it, let me know.